Bismillahirrahmanirrahim. Assalamu alaikum second year. Hope all of you are good, safe and sound at home. My dear students, as we are discussing chapter number 2, that is S block elements, and in the previous lecture we discussed about the peculiar behavior of lithium. Today we will discuss about a peculiar behavior of beryllium. As in the alkali metal, the first member of the group, that was lithium, it showed different and unique behavior than the other member of its family due to its small size, high electronegativity and less electropositive character. Same is the case with the beryllium. Beryllium, being a small member of its group, it has different and unique character from the other members of the family. This different and unique character is called peculiar behavior of these elements. Okay, students, as we move from top to bottom in the periodic table, the atomic size increases. So the beryllium has smallest size from all its family member. And if we talk about the melting and boiling point, students, we have already discussed as we move from top to bottom in the periodic table of first A and the second A group, the melting points and boiling point decreases with increase in the size of the atoms. And if we talk about the electropositive nature, when we move from top to bottom in the periodic table, the electropositivity increase due to increase in size of the atom. As the hold of the nucleus on the outermost electron is decreased, thus the electropositive character is increases. And if we talk about the electronegativity is the ability of the atom to attract the shared electron pair towards itself. As we move from top to bottom in the periodic table, due to increase in size of the atoms, the electronegativity is decreases because hold of the nucleus or the attraction of the nucleus for the incoming electron is decreased, thus electronegativity of the atom is decreases. So for first member, the first member has least electropositive character, high electronegativity and the smallest size. Due to these properties, that is least electronegativity, highest electronegativity, least electropositivity and the smallest size from all the group member, the beryllium show the different behavior from all other member of its family. Now let us look at, so there are some points, these are 6 points in your book which are about the peculiar behavior of beryllium. Students, as it's due to its small size, the beryllium is hard. It is hard as iron. The other group member, these are group 2A members, which these are relatively softer than the beryllium, and these are relatively softer, but the hardness is more than the group 1A elements, because when we move from left to right in the periodic table, the size is decreases. Due to decrease in size, the hardness of these member is more than these elements. Okay, now the second point is that the melting and boiling points are higher for beryllium as compared to the other family members. Students, we have already discussed the trend of melting and boiling point. When we move from top to bottom in the periodic table, the melting and boiling points decreases, so the beryllium has highest melting and boiling points. If we talk about the oxidation of beryllium, when beryllium is put into the water, it forms oxide layer on its surface. Due to this oxide layer acts as a waterproof agent and it resists the oxidation. So this beryllium oxide layer which is formed at the surface of the beryllium will help this beryllium to become waterproof, and this beryllium is not a good reducing agent. Students, look at this. This is the magnesium, the second member of group 2a. These are alkaline earth metal. This, for example, when it reacts with water, it reduces water and oxidize itself, thus it is the reducing agent. As it remove oxygen from the water, thus removal of oxygen is the reduction. As water is reduced to H2, so the agent which is reducing the water is magnesium. So magnesium is the reducing agent here. But beryllium do not reduce water as magnesium can reduce, because after some time the beryllium oxide layer is formed on the beryllium, and this beryllium oxide prevent water from penetrating into the beryllium. Okay, now moving toward the fourth point, that is the beryllium oxide which is formed, it acts as the resistant toward the complete oxidation. So as it acts as a resistant and a protective layer, so acids do not attack on the beryllium metal, but all other metals are attacked by acids. Students, beryllium is the only member of its family which react with alkalis and form hydrogen gas. When, for example, beryllium when react with NaOH, that is sodium hydroxide alkali, it will turn into sodium berylate. That is, there are 2 Na, Be2O, Na2BeO2. So it is the beryllium sodium berylate, it is a salt, and the hydrogen gas is released. But all other members do not react with alkalis directly. If we talk about the oxide of beryllium, the beryllium oxide is amphoteric in nature. Amphoterics are those substances which react with bases as an acid, and when they come in contact with acids, they behave as bases. For example, there is a beryllium oxide when react with H2SO4. We know H2SO4 is the king of acids, so here H2SO4 will behave as an acid, and BaO will behave as a base. Okay, now this beryllium oxide, that is a base, when react with acid, it will form salt and water. This beryllium oxide will change into BeSO4, and here H2O will form, that is water. Okay, now when the beryllium oxide come in contact with alkali, that is strong alkali NaOH, it will act as an acid. In the above case it was acting as a base, but in this case it is acting as an acid. When this beryllium oxide react with NaOH, it will form salt and water, and this salt is same as that was in case of when beryllium react with NaOH, that was sodium berylate. This is the formula of sodium berylate, that is Na2BeO4. Students, hope this will helpful for you. If there is any question, you are free to ask. Thank you. Allah Hafiz.